Hey guys, today we're going to solve LeetCode number 399, evaluate division. So we're given a list of equations in the format a divided by b equals k, where a and b are variables, so they're represented as strings, so they're variable names, and k is just a number. And then we're given some queries, and we need to return the answers to the queries. And if we have no answer, return -1 for that query. And the input is always valid, we don't have any contradictions and such. So for example, here you can see a divided by b is equal to 2. So for example, when they ask us what is b divided by a, we need to tell them that it's equal to 0.5, right? And for things like we do not know, like here we have x divided by x, we don't know that because we don't have any information on x, so we return -1. And I guess one could argue that this is definitely 1, but you know, the problem is asking us for this result, so we'll have to go by their definitions. So this problem has actually a graph-like solution. So we're recognizing a graph structure in the way that if I have something like a divided by b equals something, and then I have b divided by c equals something, I can construct edges between those values with an edge weight representing the relation between those two numbers when one is divided by the other. So yeah, we're going to build a graph with that. So our graph is just going to be an object, so a map, and then we're going to use a zip function that I just borrowed from a Stack Overflow post. So we're going to zip together the equations and their results, and we're going to take the dividend and the divisor and the result from the values array, like this. So we zip together the equations and the values with this function that I borrowed from Stack Overflow. And now we need to make sure that in our graph, there is something in the key dividend and in the key divisor. So if there's already something, that's okay. But if there's nothing, so this would be undefined, then we want to put there an empty object. Okay, so like this would be the same as a default dict in Python. And then we need to add to the graph, to the outgoing edges from dividend, the edge that goes to divisor with a weight of result, right? So this is the first edge that we are adding. It's the edge that goes from dividend to divisor with a weight of result. So what we're saying is we're saying if we divide a dividend by divisor, this is the result that we get. And now we also need the inverse edge. So we're going to say if we divide the divisor by dividend, then we get 1 over result, right? So this is just basic graph construction. And now that we have a graph, we can, for every query, we can run a breadth first search on the graph and see if we can get to a result. So we're going to return the queries mapped. So for every query, we're going to take the result. So we're going to have a function get result of that query, which is going to get the result by doing a breadth first search on the graph. So now all that's left is to implement the breadth first search. And as you know, for a breadth first search, you need well, first of all, the input parameters, of course, so dividend and divisors, just given by the queries array. And then we're going to have to do some checks because of the problem statement. So first of all, like even if the dividend, if the divisors are equal, we still need to check if there is nothing in our graph about them. So if we have nothing in the dividend in the divisor, we actually need to return -1, even if they are equal. And though in a breadth first search, we are going to need a visited set, and initially it has our dividend. So this is the element that we're going to have in our queue. So you know that in a breadth first search, you need a queue. And so we're going to set the initial visited set to have the initial value in our queue. And in our queue, we are actually going to put an object. So we're going to put the current value and the result that is given by this current value. So initially it is 1. And why we do this is because if the dividend is equal to the divisor, we actually want to return 1 straight away. So this is going to take care of that. Okay, and now we can start our breadth first search. So for every element in our queue, we destructure it into current and result. And here you could see that, for example, if dividend was equal to divisor, here we would be entering into this branch, and so we could return a result, which is definitely 1, right? But what if the current value is still not equal to the divisor? Then what we want to do is we want to go through each children of the graph of the current value, right? So these are basically all of the edges, so all of the destinations with all of their weights. And here you just need to pay attention, because like if this is undefined, you want to use an empty object instead. So yeah, just a quick trick there. And yeah, so we go through all edges of the current value and we add them to the queue if they are not visited yet, right? So if they are not visited, add them to the visited set so that we won't add them again, and then enqueue a new result in the queue, which is the current child, and the result is just the previous result multiplied by the weight of the edge, right? So you can see that we're basically traversing all edges and keeping track of what the result is after traversing that edge, and then we're pushing it to the queue. And yeah, if we end up out of this loop without ever returning, it means that we do not have enough information in the equations and values, and we can't determine what the result is, and so we need to return -1. So that's it. I'm going to show you that this works. And I think this used to be a hard problem for me. You can see that I had a lot of wrong answers, but nowadays I can solve it in like 10 minutes. So yeah, just recognize the graph structure and remember, like, this is a simple breadth first search. It's not even a level order traversal. So you need to be really familiar with this kind of algorithms. So this is it from me today. Thank you for watching, and bye.